There we go. Okay, let's start again. If we're looking at this triangle here, we have a 45-degree angle and a 45-degree angle. Yes. It's an isosceles triangle, right? Does that make sense? So guys, we know that if those two angles are equal, then the sides opposite those angles will also be equal. That's actually what the reason is, right? Sides opposite equal angles. So if that one is 8,3, that side is also going to be 8,3. Alright, does that make sense? It's fine if you use Trig to actually calculate that side, but you didn't have to in this case. Right. So what you would have to write for that is, and now again, they can label this triangle, which is really frustrating. Yeah, you could label them if you drew, because you guys will draw the triangle. Okay, I will label them, but guys, if you didn't and you are using 8,3 in your calculation, then you can just next to the calculation right there. I'll show you now when I'm actually writing it out. So I'm just going to say here AC is 8,3 units, and the reason for that is, guys, we know that when it's an isosceles triangle, and I'm saying that the angles are equal, you write angles opposite equal sides. When we're using the fact that it's an isosceles triangle to say that the sides are equal, we're going to say sides opposite equal angles. Okay, so we have to write that piece. Sides of equal angles. Right, so when we're saying that the sides are equal, we write sides opposite equal angles. Okay. You cannot write isosceles triangle, please. You're not going to mark for that. Okay, now after that, that's quite simple, right? Because now if we're looking on the at the triangle on the right, we now have two sides. We're looking for that angle, right? Which sides do we have? Opposite and hypotenuse. What is that sign, right? So sine x is equal to 21,1. No? No, I'm just 8.3 over 21,1. All right, so then x is going to be, and guys, this is step that you don't have to write down. Okay, you don't have to write sign to the -1 of that fraction if you don't want to, but you can. So we're just going to press or type into the calculator shift sign 8,3 over 21,1, and the answer is 23,16 degrees. Okay. But if you use trig in this triangle to calculate that side, it's fine, all right? So you could have said, for example, okay, I have 45 degrees. I'm going to say tan of 45 is equal to AC over 8.3 and then solve for AC, all right? But you obviously then were supposed to get 8,3 for that one as well. What was the rounding here? They just said find the value of x. So I prefer to round to decimal. I'll find that one. Okay, let's look at B. Let me just all right, what are we going to do here, guys? We need to find x, which is this side over there. Yes.
You have one
okay, so you're saying
and then the right angle to
okay, so you're saying that this whole angle is 45 degrees. So we agree with that, guys, if we're looking at the whole triangle, all right, the big triangle, that is 45 degrees. We're going to write it down, okay? And then if we're looking at the smaller triangle, right, which again is not labeled, irritating, but I will label it now. That smaller triangle is 90 and 60, so that inner angle there is going to be 30 degrees. So what we can do is we can work with the big triangle, right? And if we're looking at the big triangle, it's similar to the previous question. We have 45 and 45, meaning that it's an isosceles triangle. Right? The big triangle is isosceles. So that is 80, and this whole side is also 80 meters. Right? Because it's an isosceles triangle. Sides opposite equal angles. Same reason as an A. But we need to find X. But unfortunately, I can't look at that triangle and say, oh nice, I'm going to use trig in that triangle. Remember, the trig ratios only work in a right angle triangle. So what we need to do is we then need to work in the smaller triangle. That angle is 30 degrees. I'm just going to write it up there. In the smaller triangle, we can use trig to calculate this side, all right, that far. And then we're going to say 80 minus that is equal to. Okay, does that make sense, guys? So we are going to work with trig in the smaller triangle to get that part there, that section, and then x is going to be 80 minus that. Okay, let me see if I can fit it in here on the side. So let's just quickly write down these angles, and as you're doing the two calculations in one line, you only need to write the reason once. So if you say, can I label them again? Let's do D. I promise in case for exam they will always be labeled. If it's something that's not labeled, it makes it unnecessarily complicated. Okay, so angle A, you do, and I wanted to know that it's an topic. Oh yeah, the 50 you don't, yeah, that's true. Yes, guys, you don't actually need the 50-degree angle because we have a 60 and we have one side, so we can find the other side. Okay, so you don't have to write that 50 degree. So A is 45 degrees, angle some triangle. Therefore, BD is 80 meters, same reason as above, sides of equal angles. Okay, so now in the triangle on the left, which is triangle ABC. Now guys, if you want to, you can write in triangle ABC just to make it clearer what you're actually doing, but you don't have to. Okay, but just so that when we're looking at it again, maybe if you're studying for test or exam, we're now going to work in triangle ABC. We're going to use trig. Now guys, remember we want to find BC. We have 60 degrees. The side that we have there is the opposite side. Which side are we wanting to find? The adjacent, right? BC is adjacent. So which trig ratio works with opposite and adjacent? Tan. So we're going to say tan of 60 is equal to 80 over BC. Right, so to get BC, the subject is going to put the BC on that side, and the tan 60 we're going to bring across. Okay, so we're going to have that BC is 80 over tan of 60, which is equal to, let's see, that is equal to 46,18, yes. 1,8. Okay, so let's do this again. 188 dot dot dot. Remember, we're not rounding that off yet, but you can round it off in what you are writing there. Okay, as long as you're just working with this value in the calculator itself. It should be okay. It's just, just try and do. Okay, so now the last step, guys, x is going to be 80 minus 46.19. All right. So x is equal to 80 minus this whole thing. And you don't need a reason for that, right? That's just, I suppose, common sense. 33, 81. Oh, not degrees. Okay. There we go. Yeah, we're right. No, I'm feeling fine. We're going to move on from these types of questions now. We're going to start working in the Cartesian plane. So when you are done, copy that down. Please make your new heading. Everyone's just saying how horrifying.
I think I was eating there. I know. I don't find it on the squares. It's actually kind of last year. I just don't mind. I take
Okay, Trig in the Cartesian plane.
Yeah.
I know, isn't it nice? I mean, that's what you really do. I think we got Sorry, I actually made it too short and now it's not like on a half, so now I'm not sure. Should I move it up or should I move it down? I'm having an existential crisis. No, I was actually just nice. Good
That's a very not straight.
So make again. I think the school should pay for us also get our kids to be paid to contribute all our work. That would be so nice, and that would make all your work on so. Okay, all drawing this, right?
Oh. We're just waiting to make sure it's done. Like, they do.
No. Remember, we're waiting for our iPad.
Yeah.
No, we're waiting for our iPads, guys. Come on.
We're waiting for our.
I know.
I'll make
So nice.
How many blocks do you make?
I did 4 by or 8 by 8. I don't have a block book, so we're back here from. No? Because I use typo books for all my. It just looks pretty. I don't have to cover it. It does look pretty. I have Care Bears on the map.
Oh.
I don't even get a break. Because I simply can have a break. You know what that is? I don't think it is. Alright, guys, let's take a look here. Before we start putting trig on the Cartesian plane, we just need to discuss the Cartesian plane a little bit. I think the only time in times that you guys have actually used this was when you did straight line graphs last year. And in grade 8, you did a bit of point plotting. Yeah, you did a bit of point plotting in grade 8. Which then obviously you used in grade 9 when you did straight lines. And did you guys do transformations last year? Yeah, so that was also on the Cartesian plane. Okay, but again, working with coordinates of points and moving them, reflecting them, also. Okay, what we're going to do now is a bit different. So guys, what I would like you to write here is that on this line, okay, this is almost where the Cartesian plane starts, is this line here. This is a 0 degree angle. We're thinking of that angle there, that's 0 degrees. If we go up to that line there, which is the y-axis, that is 90 degrees. Meaning, don't write this in, but I'm just going to show you, meaning that that angle there is 90. Right? Does that make sense? Between these two lines, the angle is 90 degrees. Now, right in the 0 and the 90. Then if you're going to that straight line, guys, what is that angle there? 180. Then if we go from 180 and we add another 90-degree angle, do you guys agree that we'll get to 270? And then if we go all the way back to the starting point, we actually also have 360 degrees. Right, so 0 and 360 actually represent the same thing. We'll see as we in that. Now guys, the Cartesian plane is split up into 4 quadrants. I'm not sure if that was mentioned to you last year. You maybe it was with the transformations and stuff. So this is the first quadrant. You can just put a 1 there. And in the first quadrant, guys, you will always have positive x values and positive y values, right? Remember that the x and y axes are actually number lines. All right, the x-axis is a horizontal number line. We have 0 there. Those are positive values to the right of yes, sorry, of 0. And to the left, we will have negative numbers. Okay. The y-axis is also a number line. It's just a vertical one. Again, with 0 in the middle, we have positive values up here, and we have negative values down there. Okay. So in the first quadrant, x values are greater than 0, positive, right? So x values will be greater than 0. And your y values as well. Your y values will also be positive, greater than 0. Okay. Next up, or to the side, the next quadrant is quadrant 2. Now, in quadrant 2, we're going to have negative x values, right? But positive y values. In the second quadrant, x will be smaller than 0, negative. But your y values will be positive. In the third quadrant, the next one, here you're going to have negative x values and also negative y values, right? Because here we're now on the bottom of this number line, below 0. So x is negative here, and y is also negative 5. In the last quadrant, quadrant 4, x is now positive here, right? We're looking at what 5 of the x-axis we're looking at, but our y values will be negative. Now, guys, we are going to talk about the actual trig ratios in these different quadrants now, but I want us just to add it to this Cartesian plane. All of the trig ratios will be positive in the first quadrant. I'll show you now why that is. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive, and in the fourth quadrant, only cos will be positive. So we will talk quite a lot about the cost diagram. Starting from the fourth quadrant going around CAST, or at the cost diagram. We will do that again later. Okay, now guys, what we're going to do, remember the trig ratios only work in right angle triangles, right? We're going to draw right angle triangles in these quadrants, going from the origin up, and then we're going to connect it to the x-axis. Okay, so we're not just going to work with a right angle triangle that's just like floating in space, all right, or representing maybe something on the ground. We're going to work with a right angle triangle in the Cartesian plane. Okay, so we need to draw another Cartesian plane. Now I'm not sure. Why? We haven't done anything.
You're right.
That's it.
Yeah.
And then plotting values for one of the
length of the side. Yeah, we're gonna do it now. So that's straight. Can I put some positive signs next to this and positive? Yes. Yeah. Those are positive. Yes. Okay, guys. It depends on how big you drew your Cartesian plane. I'm gonna draw another one here on the side. All right. So that's the one next. You can decide where you want to go and how you want to. And it goes to the side, down, up the way. And guys, you know what the nice thing is on here? Look.
Oh.
What we'll do so we'll Okay, guys, we are just drawing a right angle triangle like that. Sorry, that line is not really coming from where it should be coming. Guys, the right angle triangle has to come from the origin. Okay, no, but now it's it's not working. Oh no, it's not. Why isn't it? Oh, what's happening? You guys are out, eh? I keep going to the edge of the zero. Because you have a circle, it should do that. I'm not sure. I might. Okay, it's fine. Yeah, it was going to the edge of the zero. There we go. Oh, we figured this all together. All right, now I'll put in my zero. There we go. All right. So guys, we will, no, it doesn't matter. The only thing is just you need to obviously have the right angle here where it's connected to the x-axis. And guys, that is what we're going to do always. All right, we will have to draw triangles in all four of these quadrants. Okay, but the important thing is that the right angle always has to be on the x-axis. Okay, so you'll see when we're doing examples, we're not going to do actual examples with actual numbers. All right. What I want you to put here is at this point here, at the top of the triangle. Please plot a point there, and let's call that point P. It doesn't really matter what we call that point. It can be any letter, but we'll go with P. And we'll say that this point, because now we're working in the Cartesian plane, so we are going to have coordinates as points. All right, that's the new thing. That's the thing that we didn't have when we had triangles not in the Cartesian plane. So any point, we know that we put the x coordinate first and then the y coordinate, right? Do we remember that? And we have to always put it in brackets. We separate the coordinates using a semicolon. Now guys, if this is the point xy, that means, right, that this length from 0 to this line is going to be x. Does that make sense? Say for example, that was a 2. Right? Say the x value of that point was 2. That means that the point is opposite or just above 2. Right? Does that make sense? I'm going to say that again. If this had an x value of 2, it is a bit easier to think of actual values. If this had an x value of 2, then that means that the point is directly above 2 on the x-axis. Meaning that if you're going from 0 to 2, the length would be 2 units. Right? Does that make sense? Now we're just working in general terms. Okay. So this length of the triangle is going to be whatever the x value of the point is. If it's a 2, that length is going to be 2. Because it's going from 0 to directly below that point. If that was a 5, this would go from 0 to 5, so the length would be 5. Okay, so the x length, the length on the x-axis, is always the same as the x coordinate of the point. Okay, in the same way, the length along the y-axis, right, that length there, that distance, will be the same as the y value of the point, the y coordinate. So say this was a 5, say the y coordinate was 5, then that would be directly across from 5 on the y-axis, right, whatever that value was. So that would mean that we're going from 0 to 5, so it would be 5 units. Okay. Yes. The origin. Indicate the origin. Now guys, since this is a right angle triangle, right, if we have this value and we have that value, can we calculate that length? Using Pythagoras, right? Now, for the purposes of this diagram, in the textbook, they use the letter R. Okay, but we will write underneath what R would be if we were actually to calculate it. Now, R has to do with radius, all right? So The reason for them using an R is because they are just saying you could have a circle going all around the origin in all four quadrants, all right? And then that line would be the radius of the circle. Don't stress about that too much. Okay, again, you can actually just call it OP as well if you want to. So it's going from O, the origin, to point P. Okay, so OP or R both will be correct. It doesn't matter. I'm just doing what they did in the textbook so that if you see that in the textbook, you're not confused. All right, but R you would have to calculate using Pythagoras. Now, guys, sometimes they'll actually give you this length and maybe one of the two coordinates, and you have to calculate the third coordinate. Again, you'll just have to use Pythagoras. Okay. So guys, in this triangle, we can now, let's put a theta over here. Let me just make it a bit better. Let's put a theta there, that angle there. We can now express our 6. Remember, we do actually have 6 trig ratios in terms of x, y, and r. All right. The same thing, the same rules still apply. Sine is still opposite of hypotenuse, but now we can use y and r for that. Okay, so that's actually the only thing that's new when we're talking about trig in the Cartesian plane. So, let's write it here at the bottom. Sine of theta is opposite over hypotenuse, y over r. Cos of theta, the theta of this angle, is adjacent over hypotenuse, x over r. Yes? No? Oh, sorry. Tan of theta is opposite over adjacent, y over x. Then we have our reciprocal, right? What is the reciprocal of sine again? The first letter of sine is s. So the third letter of the reciprocal has to be s. Which one is that? Cosec. So cosec theta is, that's reciprocal, remember, means swapping them around. So if sine is y over r, cosec is going to be r over y. Right? Hypotenuse over opposite. R over y. What is the reciprocal of cos? Sec. So if cos is x over r, sec is going to be r over x. But I'm not calculating, we put it on over x if you were to actually calculate. If I give you an angle. And then the reciprocal of tan is cot. So if tan is y over x, cot is going to be x over y. Alright, what will happen if you are drawing the same identical triangle in a different quadrant? Right? So say, for example, and I'm just going to draw it, we won't actually write any of the ratios down, but say, for example, I'm now putting point P. I'm just going to eyeball it. I don't know if it is going to be exactly the same place, but let's put a different point. Let's call that point Q in the third quadrant. Alright, which x values do we have in the third quadrant? They are negative, and the y values are also negative, right? What? So I'm going to put here negative x, negative y, all right, because it is relating to point P. The idea that I'm trying to have here is that these 2 points are just basically like a reflection that way, okay? Now guys, when you're actually drawing your right angle triangle, so when you, oh no, it's going to happen again. Anyway, oh, it worked.
Because your other line was connected.
Always wrong. That's a
Okay, so maybe I'll put on the point to the circle thing. All right, guys, so the idea is that these 2 triangles are supposed to be identical. Okay, they're not quite really on my diagram. Just try, and when you draw yours, try and show that the triangles are the same. No, we're not, we're just drawing. We're not gonna write it. Oh, I'm sorry. Don't worry, you can then just pay attention.
Sorry. Did I say that?
Okay, so now, guys, like I said, when we are drawing triangles in any other quadrants, the perpendicular line must always be attached to the x-axis. Okay, please remember that. Now, guys, the length along the x-axis is still going to be the same as the x value, but now, and this is what people have a bit of trouble with understanding because it is a bit different from what we've done before. The length here, say this was -2, right? And this had an x value of -2. Then that would also be -2 then, right? Do you agree? So the length would go from 0 to -2. Do we agree that the length would be 2 units? But on your triangle, because we're working in the Cartesian plane, you would have to write -2, not just 2, right? You would have to actually indicate that negative value. When we are doing numerical examples, it might be a bit clearer. Okay, but you have to indicate that since we are on the negative side of the x-axis, it will be a negative value there. Okay, so it's not actually just the length, it's also indicating the position of that point. Okay, that's very important. In the same way here, if this is -y, this length will be y units, absolutely. But because it's on the negative side of the y-axis, we would have to use -y for that length. The only thing that will never be negative is this r value, the hypotenuse. That one will always be positive, regardless of which y. Because if you were working with Pythagoras, right, and you're squaring a negative number, what's that? Positive. And then when you square this negative number, it's again positive. All right. So it doesn't matter whether you're squaring a positive or negative number, the answer, when you're finding the hypotenuse using Pythag, will always be positive. Okay. Let's do an example with numbers, sorry. So that's also what we spoke about last year, or last term, where if you're finding the square root of a number, by definition, it's not negative, it's just positive. Remember, you and I had that conversation last year. All right, guys, let's just do, I'm not sure if we'll get through the whole example, but let me just show you quickly an example here. So let's write down. No, so you'll get a positive answer, yes, but then because of the diagram, you need to put it in this thing. You'll see now when we're doing an example. Okay, so example, I do actually want to write, yeah, we'll just do the one for now. Okay, P is the point -12, 5. Yes. So guys, if we have the point -12, 5, please start, please.
I did have technical difficulties
Okay, can I talk to them? All right, guys, if you have a point negative 12.5, let's quickly think of which quadrant that point will be in. All right, because they also might not give you the diagram. Usually they will, but maybe not. Yes. We'll be in quadrant 2. Let's think that x value is negative. So if we're looking at the x-axis, it has to be on the left-hand side of the x-axis. But the y value is positive, so it has to be at the top. All right, so that will be in the second quadrant. So you'll see now when I'm drawing mine, I'm actually just going to make the other quadrants like short. Okay, you don't have to draw all 4 quadrants if we're only going to be working in the second quadrant. You can if you want to. All right, but I usually just draw mine like this. Remember, when you are working on the Cartesian plane, you have to show your y and x and your origin. Your point P doesn't now have to be to scale, but you don't think you have to make your axis go to negative 12 over there. All right, you can just plot the point anyway, and we'll say that it's negative 12.5. Doesn't have to be to scale. I'm not going to sit there with a ruler. That. And as they say that it makes an angle, of alpha in the anti-clockwise direction with the positive x-axis. So this is the positive x-axis, right? Anti-clockwise is that way. So they're saying that from this line to in line with this angle, this point, we have an angle of theta. So how we're going to draw that is you're going to connect that line to the origin. And then this is the angle alpha. Did I say theta just now? Okay, so let's see. That is the diagram. Okay, so we're to give you this diagram, that's also what it would look like. Okay, we can also draw it ourselves. Now they're going to ask us for A. Calculate the length of OP. And guys, at the moment, we can't really calculate OP because we don't have a triangle there, right? We just want a point and a line and an angle. So what you need to remember to do is to now actually connect your right angle triangle, right? You are going to create a right angle triangle there, always attached to the x-axis. Okay, so that is something that you need to add in yourself. Okay, so we're going to add that thing. That is a 90-degree angle. And now, using the coordinates of this point, we are going to fill in the lengths of the sides. Okay, so like we said, the x coordinate is the x length. But guys, because it's negative 12, we have to work with negative 12 on our side. The y coordinate is the y length of this triangle, and that is 5. Now, if we are working with these two sides, we can find the third side using 5. Okay, so OP squared is equal to 5 squared plus negative 12 squared. Or guys, if you want to, you can actually try 12 squared as well. You don't have to say negative 12. Yeah. Yes, it's a Pythagoras Triple. Yes, you can. Yeah. All right. Okay, Pythagoras. So guys, if you know that 5, 12, and 13 is a Pythagoras Triple, you can just write that OP is 13. But then you have to write as your reason Pythagoras Triple or Pythagoras. So from here, OP, that's 25, that's 144, together 25 and 144 is 169. The square root of that is 13. Okay, and you would then pull that in on your diagram. Yes, I know. Guys, your homework, just very quickly, take also 2 minutes left. Calculate the values of the 6, the sine constant, cosec, sec, cos of the 6 Trig ratios of alpha. In this triangle, now guys, we are going to, and we don't have time, or I don't have time to explain it now, but you're going to use that angle as alpha, okay? I will explain it when you graph this. So all you need to do is in this triangle, you're going to say sine of alpha is 5 over 13, right? Opposite over hypotenuse. And then you do that for all of them. Okay, that's all you're doing for all of them. It's not actually, but we can use it, yes. But I'll explain that. Sorry, it's quite a long explanation. I don't have time for that now. No. Okay, so that I'm going to explain on Tuesday.
Sorry.
It's a long explanation. I will explain on Tuesday. Sorry, we have run out of time. But use this inner angle, guys, with the right side alpha, cos alpha, and alpha. Okay, I will show you on Tuesday why we can do that. And if you want to. Thank you, grade 10s. Have a lovely weekend. I will see you on my